Another one, sample 4. You can go to sample 5 too. If you had something in sample 5 you'd rather see, we can go to that.
16.
In sample 4. Okay. And I think I'm not going to add anything new to the homework here. And so we should keep where it is. Really like to finish up these packets by next Wednesday. I mean, that's when the multiple choice last multiple choice final is. And so I might as well have them done by then so we can focus on kind of free response and moving on to other stuff. So, so this one right here, 16. Okay, volume of a sphere is increasing at this rate, and they give you this. So we would want the volume, so we'd want V prime. And so this is like 4/3, bring it, and that's 12. So V prime is 12. So V prime would be, bring the 3 down in front, would cancel that, it'd be 4 pi r squared r prime. So this is related rates. This was another thing, I had on my review sheet of problems we have to make sure we know how to do. And so that's got to equal 12. They also say when the volume is 36 pi, so you can take 4 pi r cubed over 3 and set that equal to 36 pi, because that is the volume. And then they want to know how fast the surface area is increasing, so that'd be S prime. So we bring the 2 down there, that'd be 8 pi r prime. So that's what we're trying to find. So we need some things to plug in. I think this one looks like we can get r from this. So the pi's had canceled. If we divide by 4 here, that'd turn into 9. If we times by 3, that'd be 27. I think I did that right. Okay, so if we just, if I got no calculator, instead of timesing the 3 by the 36, the numbers just get bigger. I just divide by the 4 first, and then the numbers get littler, so I can do it in my head easier. That's just strategy, but whatever. So you get r equals 3. So it looks like we could put the 3 then in here, and then we need r prime. And let's see, if r is 3, we can come over to this. 3 squared is 9, so it'd be 36 pi r prime equals 12. So r prime would be what? 12 over 36 pi, which would be 3, 1 over 3 pi. I think I'm okay with that. So that cancels, that can't, okay. 8. Okay. R is 3, put that in there, use that other information to find r prime over there, and then things cancel nicely. Okay, anything else? Velocity of a particle is given by a third-degree polynomial. The roots of p are all in the open interval 0 to a. Which of the following statements must be true? Okay, so a third degree, a cubic, right? How many roots can a cubic have at most? Cubic can have 3 roots. It can go up and then down and then back up again, and it could cross 3 times. And this is the velocity. No, wait, the velocity is given, yeah, okay, so this is a velocity curve right here. So the velocity and the roots are all from 0 to a, okay? So they're all on the positive side of here. So the velocity will be 0 at least once, yes, because a cubic could just kind of do that, right? So, but it's got to cross at least once. And it could be at most 3, okay? So I would say that is true, okay? So we've eliminated those. Okay, in the interval 0 to a, the particle moves both left and right. I would say that's got to be true, isn't it? I mean, that velocity curve's got to cross one time. Could it just touch? No, I don't think it can, right? I mean, if velocity curve's got, even if it just touches, I mean, it can't just keep going down. It's got to come up and go through, right? The tail's got to go opposite direction, so it's got to cut through. So the velocity's got to be positive at some point, negative at some point. So it's got to move both left and right. Okay, so it's got to have number 2 there. The total distance traveled by the particle is given by that. True or false? thing I had on my list of things to review is total distance travel. That kind of idea. Okay, good ones. Keep going. Anything else? Anything else? Anything on sample 5? Anybody started on sample 5?
2 to 23.
Okay, the arc sine rule for derivative, right, is that. So here we have 3/4 x, so that'd be 1 over square root of 1 minus, and then you square that, that would be 9x squared over 16, and times the derivative of the inside would be 3/4, right? Okay, so then it's a matter of equating this. Okay, now it's not something we've done a lot of. This is just an algebra thing. If, you know, in a college probably Calc 2 class, you get into antiderivatives especially, because when you're doing, you know, go the other direction, when you're looking antiderivative and you see this, it makes you think arcsine or arccosine, right? And if you get a 1 plus x squared, you think arctangent. But you always have to have a 1 here. A lot of times you don't have a 1 here, but you can always get a 1 there. That's the thing. You can always get a 1 there with algebra. So you do that a lot when you're doing antiderivatives, actually. So it's kind of the same thing here. So we know this, so it's kind of working it in reverse. Well, what we can do inside of here is we could take, well, not inside, but we could take and multiply the bottom here, okay? We could take the top and the bottom of this times square root of 16, okay? Which is times 1. Now, why would I want to do that? Well, first of all, to multiply into a square root, you got to have another square root, like square root of, right? Square root of 2 times square root of 3 is square root of 6, right? So what I'd like to do is get rid of this 16 down here on the bottom, so I need to multiply by a 16, but to multiply into the square root, I need square root of 16, okay? And then, so I got to do that to the top and bottom, okay? So now when I do that on the bottom, I now have a 4 on top and a 3 on top, which would be 12, okay? Now the bottom here, inside, I would now have 16 minus 9x squared. And then, but there is still this 4 sitting there. Okay, there still is that 4 sitting there. Actually, I could have canceled it, I guess, with that and that. But anyway, okay, so see how that works? So I multiply this through and I get 16 here, and then the 16 cancels that one there. And now this 4 cancels that, and I get 3. And so, now okay. So now working that in reverse, if they ask you to do an antiderivative with this one, what you would do if this was an integral problem, you know, I'd probably bring the 3 out here, and then I would factor out a 16 and make this 1 minus 9/16 x squared, just do the reverse of what I just did there, right? And now that's this square root of 16 is a 4, so I can bring that out as a 3/4. And now I think, now I can write that as 3/4 x all squared, and now I can say, okay, that's an arc sine. That's an arc sine with 3/4 x in the inside. So that's how you would do one of those if you were doing the integral and wanted to get a 1 there, so you could match it with the arc sine. Okay. All right. What else? The other option. Well, that was kind of really fun. Okay. What else? I was going to say you can do the derivative of each of these, but that's not right. You're doing the derivative. You got to do the antiderivative of that, but that's not very helpful. Oh, what about this one right here? Nobody asked about it, but right away when you see that, hopefully you think what? Derivative. Derivative of tangent 2x, right? Which is secant squared 2x, kick out a 2, right? Secant squared 2x, kick out 2. That's intended to be a 10-second problem, right? I mean, that's one where you just look at it and say, that's derivative, tangent 2x, which is secant squared 2x, kick out a 2, okay? Um, all right. Anything else? Example 4. Example 5. Okay. Tomorrow or Monday, if you have a last, I don't know if that does much good, but if you do have one or something, write it before we do the test, we could. Because we got 50 each time, we got 55 minutes on Monday. Okay. All right. Let's take a look at this problem right here. This is from the 2008. So one of the things I want to do is as we go along here and we get closer to our free response questions and closer to the AP test in general, is just kind of trying to find some problems that are a little bit more out of the ordinary maybe than have shown up on AP tests in the past. It might be time for them to show up again. But also at the same time, make sure we're solid on the basic stuff too, as I'm talking about. Okay, this was from 2008, so it's been a while ago. And I remember there was a lot of discussion on the old discussion board, the old AP calculus after this one. This one kind of came out of left field. And then I haven't seen one real similar to it since, so I'm just kind of waiting for this one to come back. But a lot of this isn't too bad. Okay, so now this is let me see, I think this is a calculator one. Yes, this is a calculator one. Okay, so you got the sine and you got the x cubed. Okay, so this one is clearly the sine function right up here. Okay, and this one is the x cubed minus 4x. Okay, so find the area of R. So we're going to just work parts of this. We're going to talk through a few parts of it. And then I'll give you a chance to see what you think. But the first one, find the area R. Okay, so what are we going to do? Top minus bottom, right? Put a strip in right here to here. We're going to go 0 to 2, right? And we're just going to have that curve minus that curve, right? Type in our calculator, and we got it. Okay, probably worth 2 points, maybe 3, for the setup and the answer. That's it. Okay, so that should be pretty easy. The horizontal line y equals -2, okay, splits the curve into 2 parts, splits the region into 2 parts, okay? Write but do not evaluate an expression for the area of the part of R that is below the horizontal line. Okay, so we can do that. So top minus bottom. 2 minus the x cubed minus 4x graph. And -2, thank you. -2 minus that from, you're going to have to go onto your calculator, you're going to have to set this curve here equal to -2 and do a solve, and you're going to get 2 answers. You should get 2 answers, and so that's where your integral will go from A to B. Another thing I should tell you that they do kind of recommend, if you don't have to do this, but if you do that solve, you could write down in your work here, you could write down A equals, let's say this was 0.632, and B equals, and this number over here, say it was 1.749, You can write that down, write those numbers down, because maybe you need them later in the problem also. And then when you set up your integral, you can actually just go integral from A to B, if you've got those defined down here. So you have to put those numbers in, okay? When you type into your calculator, though, you should type a whole bunch of decimal places, 5 or 6 or 7, right? So your final answer is, they even recommend storing them in your calculator, storing that long, big decimal as an A, storing it as a B, and then you just type the integral from A to B, doing that as well. As long as you type it 6 decimal places or so, you should be fine, okay? So that's not too tough, right there. Okay, the region R is the base of a solid. For this solid, each cross-section perpendicular to the x-axis is a square. Okay, so we can do that. Still top minus bottom, and square that. So you're going to have sine minus x cubed minus 4x, and it's going to be all of that squared, and then it's going to be the integral from 0 to 2. right? So you got a square, that strip is one side of the square, you square it, okay, you got it. Okay, so all of that was all well and good. It was this part. The region R models the surface of a small pond. Okay, so that's the top of the pond. At all points in R, at a distance x units from the y-axis, that means, you know, here would be x units from the y-axis, here would be x units from the y-axis, here would be x units from the y-axis, here would be, you know, as we move across x units away from the y-axis. The depth of the water is given by h of x equals 3 minus x. Find the volume of water in the pond. Okay. So, what kind of a volume problem is that? Is it revolving? No. It's more like C, isn't it? What they're telling us is there are these slices, okay, that go down. Here's the top of the pond. So instead of the base of the region and coming up off of the page are these squares, what they're telling you is now going down below. It's the same thing, doesn't matter. Which is now going below the pond, but nobody had ever really seen a problem like that. But it really is the same thing, going down below the pond. What have they given you? What's the 3 minus x? How far down below it's went, right? So what shape are the slices going to be? They're just going to be rectangles. They're going to be this length, right? And however far they go below, or if you imagine the pond coming up above, that depth, right? Well, that depth is 3 minus x. So what are you going to do? You're just going to take 3 minus x. I mean, I think once people, the hardest part was people just couldn't get over the fact this was different. You know, this is not different. This was not like ones we've seen before. But then this is just sine minus the quantity x cubed minus 4x. So it's the strip. So this is the length of the rectangle. And then, of course, the dx would be the thickness of it. And there you got volume, right? Because remember, it's still slices. So it's still slices. And the whole formula for, you know, slices is this. The integral of the area, okay? Now, I've got another one to talk about later, another day, but setting up an integral for the volume, remember, as long as it's slicing, as long as there's slices, the only difference is shell. Shell's the only time we did something different, and you don't have to use shell. Shell doesn't show up very much in Friedrichs spots, to be honest with you. They usually have volume problems that are set up to be slicing ones, okay, almost always. So, it's just a matter of getting area. Think of what the slices are, getting area. Well, here's the length, and then going down below, it's got a depth, which they told you, and so therefore it's just the length, top minus bottom, times that depth, and then dx is thickness, you get volume, okay? And then from 0 to 2, okay, just like that. And then just to help you see it a little bit, there was I do have one of these. This was this is kind of a picture of it to help you picture it. So there's the top of the pond, the surface of the pond, and then down below, right? So where that line is, so as you go farther, it's less and less deep, right? The bigger x gets, 3 minus x gets littler. So at the very beginning, 3 minus 0, when x is 0, it's deeper. Then 3 minus 1, the depth is 2, and 3 minus 2, the depth is 1. I think it only goes out to 2, so, right? And so that's kind of the pond right there. Okay? So anyway, that was the final answer for that. All right, work time. Okay. I will be adding a new kind of some free response kind of stuff in. If not on Monday, probably on Tuesday a little bit. So let's try to by Monday. Let's try to have a pretty good handle on these packets here. Okay. And then, the motion one we're going to hand in on Monday, remember? Yes.
Is the scale on the final going to be the same as the midterm?
Let me show you that.
No. Lucas Arts kid on his face. He ran like a 49 race with sample style. I will look. Braylon, I think that's solid, like, 10 inches. I mean, right.
The question was asked about the scale for the final, and as soon as I find it, I'll show it to you.
Just so you know, I'm going to California here soon.
Okay.
I'll be there the 10th to the 15th. That's
That's
Monday.
like right up to the end of your.
Monday to Tuesday. Monday to Tuesday, I believe.
Yeah, flip that over. You're almost there.
Yeah, so I'm listening to 10 to the 15th.
Okay, our finals will be over, but then your the last day for seniors is Wednesday.
Well, I'm a junior.
Oh. Well, right, but I'm just saying.
So you're not doing much after that?
Yeah, the problem is it'll be your group paper, but so you might leave your group hanging. But you actually might be working. You actually might have a lot of that done by the time you leave. And then it might just be the last group problems we do, but then since you'll still be here after that, you'll have time. So that actually won't work out too bad. Okay.
Yeah, no, the last 2 years of state has been terrible.
All right. Scale. Not that it matters a whole lot, but it's kind of nice to know. Okay, so the multiple choice, no calculator, the one on Monday, historically the raw percentage has been about 45 to 56%. Kind of from the low to high end. And so the cutoffs for A, B, C, D, 20, if you get 26, now there's 28 questions, right? So 26, 27, or 28, you get 30 out of 30, right? So that's your goal. If I'd only miss 2, you can get 30 out of 30, okay? 20 out of 28 will get you an A, 15 out of 28 will be 11 out of 28, 7 out of 28 will get you passing. Okay? And if you get 0 out of 28, assuming you attempt them, you do not just turn it in after I hand it out, you still get 13 out of 30 points if you miss every single problem. Okay? So I want to see some work in that booklet of problems. Okay? So the calculator one's usually a little better. You can see it 58 to 72 is kind of the average. But it takes a little higher percentage to get an A, I believe, if you look at that. Well, not probably a lot different. 13, so again, if you miss 1, you can still get 30 out of 30. 13 for an A, 10, 7. 4 out of 17. Again, that's about 25%, so that's about the same. It's about the same scale. So probably scores are a little higher on the calculator one overall. Okay? And then the free response. Now, I did misspeak the other day. I think somebody asked me about how much they're worth. I said it'd be 4 30-point grades. Actually, it's 2 30-point grades and a 60-point grade. And that goes back years and years ago when there used to be 6 questions. You could use a calculator on all of them. That was before the calculators got fancier. So then they started doing no calculator. So I add the 2 together. So after our first day of free response, you won't get a grade for that. I put both free responses together and make it a 60-point grade. So it's all the same in the end. But just for comparison, now the raw average on that's 53 to 75. So about the same as the calculator one, but a little higher. Again, you get partial credit. So 54 points. So there's 6 questions, and they're each worth 9. They have 9, partial credit points. You can get 9 points, show your work, do this, do that, the whole thing. So if you get 50 out of the 54, you can get a perfect score. Okay? And then those are the cutoffs there. So anyway, for what it's worth, that's what it looks like.
Does anyone actually miss all of them? Just
missed all of them?
Yeah.
No, I don't think so.
Has anyone ever gotten like an F on?
I don't think anyone's ever gotten a zero. Has anyone gotten an F on a part? Yeah. There was a time where you could get a negative score, you know, when they had the old penalty for guessing, you know. Like, is the SAT still do that?
Yeah.
They got rid of that
I
too?
got rid of that on the SAT, but the subject test on the.
The subject test too. And and College Board's in charge of the AP test and the SAT. And so, so when they had the penalty for guessing, you got 4 points right for every one you answered right. You got 0 points for ones you left blank, and you got a -1 for ones you answered and got wrong.
It's
So it's possible to get.
Just writing my name and.
No, because then it's a 0. I mean, but at least it wouldn't have been negative. That's true. At least it wouldn't have been negative.
Can you explain number 29?
Okay, this.
Your 2 was my.
10 years ago.
Yeah, because this
And they could have made it better.
is just basically
Second one.
the inverse function.
I didn't even watch.
But this would be
So bad.
I just watched it on
2
TV and I'm like, this is so dumb.
People were saying how bad it was.
would be like saying,
Yeah. I've seen some YouTube videos.
let's see what the easiest way to explain this is.
That's not like, okay, this is like the inverse of the actual function, and then this is the inverse of.
Yeah, well,
So that's what they
solving.
Right. So like if you get y equals x squared, if you call that f,
I was just trying to put.
then if you interchange, so then if you interchange the x squared, maybe it makes sense. This is f inverse. Okay, right here. So now, f inverse of x would be, so f inverse of x would be solving this for y. So f inverse is this. If you solve for y, you get that. Let's say. Okay. All right. Which would be the mirror image. So either way you do it, either way you do f inverse is the mirror image. It's just a matter of whether you would have this, or if you do f inverse y, then that would be like having this. Does that make sense? Okay, so you're right. F of x would equal x squared, like that. And f inverse y would equal y squared, because that's f inverse, but this would represent x for that function. Okay, so now these would be y squared is that, or x squared is that, right? So it's still inverse. So you would have, so f inverse y would be 0 to b, just like f inverse a would be, or f of x would be 0 to a. So I would agree that those two are true.
Yeah, I know. One of that first, and then the middle one.
And did you look at the answer book?
Yeah.
And it's got all three? Okay, so here's why, so let's look at this one. So this one, but understand that f inverse x equals this is the same as f inverse y equals that. In other words, it's kind of like saying y equals x squared. Y equals x squared is this parameter. X equals plus or minus square root of y is also that parameter. It's the same thing. So this one is the same. So these two are the same. Okay. It's just one's in terms of y, one's in terms of x. So it's the same picture. Zero B.
He is a man. I like when he's like, where he's like, oh, I don't know, you just pick what's on now.
So this would be like having.
No, what is it? This is instant kill. No.
You're in
Oh, yeah, yeah. It's not that they're saying the same thing, but they give the same area. So in other words, this would be in terms of axis. So that means, that would be this area. Okay, so this area that, now, when you do the inverse, now all of a sudden, your picture's like this, where this is B down here, this is A. You see what's happening, because you're reflecting it in this X equals Y line. So your inverse function would be down here.
Got it.
And so that's B.
That's why I was
Right.
thinking, why that?
Why
I was
that
still
would
thinking
work.
0 to A.
Right.
Okay.
So now
that
if this
makes
is on the
sense.
X, so this is F inverse. Now this is the F inverse picture, and if you're doing X's, you're doing vertical strips. So that's why it's doing that.
Okay.
And then this one would be having Y, that would be having horizontal strips on this one. So that would be having horizontal strips here, and that's why.
Okay. Thank you.
Okay.
Okay, but what better news agencies are there than the one Exactly, so he's basically just saying. Well, can you send the ones that's right?
Hey, Jade, do you have that worksheet 3? Did you give me that? For some reason, I didn't have that. And I just gave it back to you this morning. Okay.
Yeah, so we get them just this. I wonder if.
Okay, so. Why is he been in all together?
There's a full movie for Ant-Man, and then he's in all of it.
Wait, what? Spoiler, come on. I didn't know it, so you did spoil it for me.
It's not.
Yeah. Yeah, well, I forgot about that until now, so.
Good, so it's only the movie.
I would have said, hey, that one reason I just.
Yes.
Here's my thing is Cap. Here's my thing. Cap is much better. I don't know if they have this. Yeah, it's Chris Evans. I think Chris Evans should be between.
I don't Yeah, that's how it's.
But they're not. They're cool. They're like.